Hello, welcome to week 5 of this course. Good on you, you've hung in this far. I hope you are finding these lectures, albeit video recorded ones, are useful and interesting. If we could have done these face to face back in the old days, we would have had a lot more dialogue and interaction around the material. But here we've tried to embed questions and things to prompt you to think and links for you to follow up afterwards. So like every other week, we've got some things for you to do after you finish watching this lecture and some questions and things to help you think. In the end, again, we're not trying to give you a recipe or a best practice of how to teach mathematics. We're trying to prompt you to think about your own identity and practice as a teacher, how you can make good professional judgment, how you can design your teaching to be best for your students in your school site. There's no one best way of doing it. There's some bad ways of doing it, of course, but you'll need to work out how you are going to teach mathematics. And as long as you do that professionally and thoughtfully, thinking about what's best for your learners, I'm sure you'll do a good job. The way you do it might not be the same way as I would do it or your colleague would do it, but you need to find out what works best for your kids. So this has got lots of things to try and help you think again, as we look at how mathematics relates to content knowledges and linking it to concepts and other ideas. Here's some of the things we want to cover. We want to look about conceptual understanding and making connections across mathematics. We want to look at some of the precursors for maths learning, and these things aren't just specific to mathematics. These will be things that you probably have covered in your general education courses. But here we want to look at how they might relate specifically to learning mathematics, and how when you're teaching mathematics you can help build kids' general academic skills and capacities. And finally, we want to give you a list of some points of some developmentally appropriate maths ideas for young children. Again, for you to consider as you think about your teaching in your upcoming practicums and in your career. So the first thing is about building conceptual understanding. And when we think about that, we've got to think, what's a concept? Now, a concept is really just a picture in your mind. It's a way of understanding something. And even if you think of something like a number is a concept. It's not a real thing. It's just a picture that represents something. So if I say to you the number 3, you have a picture in your mind of something that would represent 3. So that would be like a concept. A skill is a proficiency or a procedure that you can do, or a strategy, something like that. So adding 3 numbers together. So you can see that they're different, but of course they're related. Concepts are really important in what you do when you know mathematics. The skills are what you use when you do mathematics. And of course you need both of them together. Having one or the other on its own isn't enough. And so problem solving is when you pull these things together. Again, there's a link for you to follow there, and I think that will go through that in more detail. So one of the things we know about maths education is often students finish their maths learning and they don't have a big picture of mathematics. They just have lots of siloed and separate understandings, and they don't understand that it all hangs together as a coherent whole. They don't understand that some things are related, and often that means that students have trouble using mathematics because they might have one part of mathematics to solve a problem, often the thing you've just taught them, but they don't think that we could use something that we've learned previously to do that. So all these things are related in some ways, and it's important that you link things together. So for example, proportional reasoning is related to fractions, but it's also related to geometry and algebra and ratio and probability. When you give a probability, for example, you give it as a ratio or a proportion. What's the chances of rolling an even number when you roll a dice? Well, it's 3 out of 6 or 1 out of 2. So that's about proportional reasoning. And you can see this idea of proportional reasoning relates to all those things. Most kids will find out and think after their schooling that they're all separate. So mathematics itself is a subject of connections and links between ideas which don't sit alone but all come in a web and a linked conceptual map of ideas together. So what can you do? Well, when you're doing these sorts of things, it's important you make your links through your mathematical thinking. And things like patterning are ways of showing that patterns exist in all sorts of parts of mathematics. It's in geometry when we label shapes. There's properties that form patterns in things, but also in algebra, which seems to have nothing to do with geometry at all. But it clearly can be related through patterning. So there's lots of ways you can make links, and one of the ways you could possibly do it is as you develop mathematical topics and ideas, because when you teach them in class you'll often divide it up around concepts and strands and things like that, key learning areas, is to build up some sort of map on the board as you do new ideas, link the new ones together and show how they're related. Pardon me. So here's some questions for you to consider. You can stop the video now and think about them, or you can come back to it later. I'm sure you all will. But first of all, what skills and concepts are precursors for mathematics learning? What are the skills and concepts, even before they start school, that kids would have to learn and know and understand? What developmentally appropriate practices with young children lead to mathematic concept development? Okay, so not just so they can repeat skills, but so they can actually understand the concept and build the concept, that mental image. And referring to some of the stuff we've done earlier, what learning theories are applicable to learning in mathematics? And we've done some learning theories here. I'm sure you've done learning theories in all your courses. Learning theories are really useful, not just because you need to memorize these theories as some abstract knowledge, but they talk about how kids learn. And a good learning theory helps you design learning for kids in a better way, because it helps you understand how they learn. Of course, we have theories about learning because we actually don't know how they learn. We can't look inside a kid's head and see what's going on. We can only guess by what we see going around, and that's why we build theories, and that's why there's different theories. So things like constructivism, behavioralism, social constructionism, all these things are theories about how we think kids learn. Which one of those, or which collection of those, help you design good mathematics learning for students? So if you want to stop now, you can, and make some notes about those sorts of things, or you want to refer back to some of those earlier lectures we had about learning theories and developmental sequences. See what you think. This is the bread and butter of you as your teaching career. When you go out and teach kids, why are you doing it a certain way? Why did you do it that way and not a different way? And as long as you can justify it, it's all good. And you'll see how the kids learn, and then you might modify it and change it again. All right, so some of the things that are precursors to mathematics learning are some of these ideas. Remember we talked about the first question there? Some of the things they develop in early childhood. The first thing we'll call identity. I don't mean people's identity. It's the idea that objects and features have attributes that identify them. So what are the things that make a square different from a triangle? What are the properties or the attributes of those things? So developing the identity or understanding the salient features of things that identify them. The second thing is that we put labels to name these things. So students, young children, particularly in early childhood, can see that the difference between two things and three things, and then we give them a name. We call this group of two objects the name 2, and we give this group the name 3. And if you're in a different country or they use a different language, they might have different labels, but the concept's the same, but it's a label we've assigned to it, and particularly relevant to the language we use. And then the third part they would learn, hopefully through early childhood and experiences prior to school, and once they get to the early years, is the properties of objects, how you can classify them and compare them based on these observable attributes that we noted at the start under identity. So, if you looked at a square and a rectangle, what are some of the properties that would help you classify them as being quadrilaterals? But how could you compare them and see that they're actually different as well? What makes them different? So that's what we mean by properties and objects, properties of objects, and how you can classify and compare them. And the last one there, of course, is counting. You think mostly kids can count before they come to school. Not always, but usually they can, and they learn this through their early childhood experiences, whether in formal learning centres situations or whether just through being around home. But often you'll see a kid who can say the number sequence, even quite young kids can say the number sequence, but it doesn't mean they're counting, it just means they're repeating the sequence of numbers that they've heard and learned. And we think that typically kids can actually count between the ages of 4 and 5. Now having said that, some kids can do it earlier and some kids can do it later. But to actually count things doesn't just mean they can say the sequence of numbers. All right, so here's some of the things that would be included in being able to count. First of all, you can recall the names of the numbers. All right, and again, this is so obvious for you that you might not think about it, but something that children have to learn and that you yourself learned when you were very young. The second thing is the sequence of numbers, sometimes called seriation. Okay, that 4 comes after 3 and before 5. They're not just a random sequence, they actually have an order. And then the third part is about assigning a number to each object. So what we call one-to-one correspondence. You would have done this in Mathematics 1. But when you have one bead or something, the number 1 is assigned to that. And when you have 2, the number 2 goes with that. And when you have 3, the number 3 goes with that. You'll notice a kid who can't do that because they'll go 1, 2, 3, 4, 5, 6, 7, but they'll point to the sequence of numbers or the symbols for the numbers, but there won't be a correlation between what they're saying and what they're pointing at. So when they can do one-to-one correspondence, they'll say 1 and they'll point to 1, they'll say 2 and they'll point to 2, etc. And the third thing is they can keep a track of what they've counted and then realise that they keep counting on. This is called cardinality, how many things are actually in it. So if you have a group of 7 things, the sevenness of it is called the cardinality of it. So these are some concepts you've probably already done in Maths 1 and you would have hopefully learned before they come to primary school, but maybe not. Sometimes you'll have to help, particularly if you've got an early years class. Now some things that relate to cognitive structures and things that aren't necessarily mathematical, but about them trying to learn things. The first one is the development of memory. And this could be a whole series of lectures on its own, how you help kids remember things. But it's about remembering, to help kids remember things, it has to be more than just rote memorization. Kids can rote memorize things and recall it. For example, a lot of kids rote memorize their times tables and recall it, but they actually don't understand what it means, what the concept is. So it's always better to start with the concept and help them understand. So 3 times 9 is 3 lots of 9. Understand the concept and then build the memorization in afterwards. It's easy to remember if you understand it. We could talk a lot more about memory, but at this stage, the main point is to remember that it's much easier to remember something that you understand rather than just memorizing something as a series of words and symbols that mean nothing to you. Incidentally, if kids memorize their times tables, they often learn about multiplication and don't ever see that the two are related. So they might be able to say 3 9s are 27, but they don't know that that means 3 lots of 9 things is 27 things. So trying to build those together gives a much richer understanding, it builds conceptual understanding, and helps them memorize things. Also, other cognitive structures relate to language and how they can manipulate concepts through language, how they communicate their ideas through language. And this is important because all of our teaching is done through language, all of the kids' learning will be done through language, and you can see this becoming important, particularly when you get kids whose English isn't their first language, or where their language skills are hindered in some way. How can you communicate things? The last one is being able to have mental representations of things, which is a bit like memory. How can I help them keep something in their memory? What's a meaningful way to have that and represent it, particularly so they can recall it later, but also so they can see it's connected to other things. I'm not going to dwell too much on this because I'm pretty sure you've done this in your general education courses before, but I'm just connecting it a bit to mathematics here. Now the other thing is developing to their informal mathematical knowledge. So when kids arrive at school, they would have a whole pile of mathematical knowledge, even if they haven't done kindergarten or preschool of some form, because just they've played with things. They've done objects, they would have counted them or used them in sets or some ways. They would have looked at the properties of things. They might have played with water and mud and sand and stuff, so they might have ideas about volume and capacity and things like that. But they won't come as an empty slate. They come with some prior knowledge. And some of that will be useful, but also some of it could be misconceptions, things that they've learned through these experiences that aren't always true. So for example, a common one you'll get is kids think that when you multiply two numbers together, you always get a larger number, because all the multiplication they might have done in the previous, either before school or even in the early school, always gave you a bigger number. So then when you try and do something where you multiply by a fractional number and the answer is smaller, this might cause some cognitive dissonance for them. Some other things you need to know, things that they might have learned. So for example, when the kids start school, you might say you're in room 7. So in that case, room 7 is not a number per se as a concept, it's a label, it's a name. Room 7 is a name. It really doesn't matter. It doesn't mean that 7 things there or anything like that. It doesn't relate to the sevenness of it. It's just a label. Probably means it's the 7th room along, but again, not always. Just go around Griffith campus and you'll see how randomly they assign room numbers. So that might help, that might cause some problems, something they've learned, and build a conception about the number because of their experiences, and you might have to deal with that, but when you're helping them to learn about numbers, for example. But the importance of informal mathematics is, first of all, it helps them develop the language of mathematics. All right, so when students arrive early at school, they will have some language related to number, they'll have some language related to shapes, they'll have some language related to time and things like that. This is not something you ignore, it is the building blocks from where you start. So when you're helping children learn, you don't assume they know nothing, you try and understand what they already know, and then you build from there. And sometimes that will include rebuilding concepts that may have misconceptions about. So also their informal knowledge that you understand from watching them do things or seeing them play or other activities in the classroom will indicate some of their early learning problems they might have, some of the misconceptions they might have. But the beauty of the informal things, it also helps students rate mathematics to the real world, or not that school is not the real world, but their world outside of school, I guess is what we're trying to say. And again, sometimes this might be a hindrance. So for example, usually before they've come to school, they might have had a pizza and they might have said, do you want a quarter? Now a quarter of a pizza, hopefully it's a small one, doesn't mean it's exactly 1/4. It means it's one of the 4 pieces, but there's no necessary an idea that they're all the same size. So they may have developed an understanding that a quarter is 1 out of 4, but they may have a misconception that those 4 pieces have to be the same size for it to be a quarter. These are all things they'll bring to the classroom, which makes your job more complex, because if you've got 25 kids and they've all brought different things, you'll have to understand that when you help them to build their understanding and conceptual knowledge of new things. But it makes it fun too, and often they'll have similar things. So here's some of the signs of learning problems for young children you might encounter. And again, we can't give you a recipe or an exhaustive list here because kids are different wherever they're from. But if they've got language problems, you might notice that they have troubles naming objects or simple directions, or they can't recall the numbers from 0 to 10, or they might give them names that aren't quite right. For numbers, instead of saying 4, they might say 4th or some other thing like that. Some of the social emotional things, and again, these are broad things that you would have discussed a lot in your other education courses, but they have trouble following simple rules, or they trouble engaging with play. They get frustrated. They're very egocentric. The world revolves around them, and the list goes on. You would have seen them during your practicum, lots of things. Now, this is not children necessarily being naughty or trying to be disruptive. It's just issues that they have that you have to work around, and how can you help them learn and adjust and things like that. How can your teaching create conditions where they can still thrive? Again, you'll find some kids have sensory motor issues, and you would have seen this often in their phys ed lessons. They can't catch or run, and they can be disorganised, and often this can relate to their growth. So you can sometimes have a child who's quite well coordinated, they're having a bit of a growth spurt, and all of a sudden they become very clumsy and they fall over and things like that. And this can relate to maths things, particularly if you're getting them to manipulate small objects or manipulatives. So just to be aware of it and try and make sure you have things that are appropriate for the students in your class that they can use. Of course, students will have almost all students will have some sort of cognitive advantages and some things that might make it difficult. So kids who particularly struggle for math, sometimes they might not be able to count, say, up to 4 or 5. They might not remember the names of colours and shapes and things like that, or they might struggle to follow simple directions. So again, as a teacher, you need to think about what are some of the strategies you can do to help them, and often providing other prompts is a useful way to help. And again, some kids might have trouble with their short-term memory. They might be able to count up to 10, but they can't count back or something like that. You might tell them something and they just don't remember it straight away. So again, there's a lot of strategies you would have learnt in your other education courses that apply equally to maths about how you can help kids with their short-term memory. And then, of course, how do you move it into long-term memory? So here we're going to give you a list of 10 points that are about developmentally appropriate mathematics for young children. So here's the first one. And again, these are not rules or formula, but just principles, if you like, to think about when you're developing your maths teaching. The first thing is try and enhance kids' natural interest in mathematics. Or the opposite of that is try not to kill off their natural interest in mathematics. Because usually for most kids, somewhere along their schooling, it's put to death fairly quickly, usually by a teacher who bored them to tears in the classroom. Right, maths can be exciting and interesting. You don't have to make it interesting and exciting. It is interesting and exciting. You just have to help the kids to see it. And of course, this is going to start with you. How can you help them develop a disposition where they want to use it, where they want to look at the world mathematically and make sense of it? So, first step, make sure your own identity is strong in mathematics, that you have a sense of interest and understand the usefulness and the practicalness, but also the fascination of mathematics. And then do your very best to inspire the kids about that. If I only could give you one principle, that would be it. The second thing is, and this applies of course to mathematics, but all other areas, when you're doing teaching, build on from their previous knowledge and experiences. No student comes to any learning experience as a blank slate who knows nothing. You need to understand what they already know and think and feel particularly about that concept, but also the things that might be related to it, and how you can build onto it, how you can go forward. So of course this relates to the concept itself, but it also relates to some of their experiences where they might have interest and that thing might be related. So for example, if you're doing fractions, obviously you want to know they understand number first of all, and they have some proportional reasoning, but also you know in their experiences they might have played football and they know about quarters and halves. So that's all part of their experience, knowledge that they bring to it. So the second principle here, and almost as important as the first one, is whenever you build some learning experience, you need to be taking them from where they are. You don't start from scratch, you don't start from some random place. You need to understand what they know and understand, and you're going to try and move them forward. The third principle, base your teaching practice on the children's needs. Not the curriculum per se, although the curriculum is important. You're there to teach children, you're not there to teach the curriculum. So start with the children's needs. What do they need to know? What are their cognitive needs? What are their social needs? What are their linguistic needs? And so that will shape your teaching. Of course, the curriculum will guide it, but more important than the curriculum is the students in front of you. And you need to connect with them, as we said in point 2, but then what are their needs? And that's where you base what your learning experiences you create would be. The fourth one, provide activities that strengthen problem solving and reasoning. So a kid finishes their schooling, they can regurgitate all the skills and algorithms under the sun, but they can't use them to solve problems and to reason mathematically. Then you haven't taught them mathematics. They haven't actually done mathematics. It would be a bit like teaching kids to play basketball, and you do sessions on the rules of basketball, you talk to them about the rules of basketball, you might even go out and practice passing and shooting and dribbling, but you never actually play the game. So you can never say that they've done basketball, they've just done basketball things. So maths, it's the same. Yes, it's good to have mathematical knowledge and skills, but these things are only important if you can solve problems, if you can reason mathematically. They've got to play the game. So make sure that's a key part of your teaching program, and that it's developmentally appropriate for the children you have in front of you. The fifth thing, make sure that the curriculum, and by that I mean what the children experience in the classroom, is coherent and compatible with the mathematical ideas. So when they're learning a mathematical idea, it is consistent with that idea, not something else. Make sure you're teaching them things that help them understand the conception, not just the concept, not just the skill itself. Number 6, allow for deep and sustained interaction with key mathematical ideas. So one of the things you may have seen over the years, particularly when you're a student, is you might have had a lesson where the teacher gave you some beautiful notes, did 3 worked examples, and then told you to do 50 exercises out of the textbook. And sometimes that's okay. Really, it's a way of building up automaticity and putting things into long-term memory after you understand it. But sometimes you need to give kids one question and give them a whole lesson to do it. Give them one question and give them a whole week to do it. So they have to have sustained and deep connection and thinking and involvement, and have to build up their resilience and keep persevering, because this is what mathematics is like. If you've ever met a mathematician who does it for a job, they would usually be solving one problem, sometimes for years. It's not just a matter of doing quick fix, boom, 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 boom. The idea is you really engage deeply with something, and kids need to have opportunities to do that. Number 7, as much as you can, integrate mathematics with other activities. And certainly there's options to connect it with all other curriculum strands of that you have to teach. Physical education, art, music, science, everything has some mathematics in it. And indeed, mathematics can work both ways. So if you're teaching them, for example, about graphs in mathematics, then make sure that relates and connects with what they're doing in science, if they had to draw a graph for a science report or something like that. Interestingly, often we get kids who come through primary school and they've learned graphs in science, they've learned graphs in maths, and they've learned graphs in social studies or something like that, and they've all learned different things, and the kids never see that it's actually all the same stuff. If they just learned it once, they could use it several times. Principle number 8, allow ample time for students to explore and manipulate mathematical ideas, to play with things. And this can be really hard for you as a teacher, as the push is on to finish the curriculum. We're always doing more and more and more and more, and the kids never get time to actually really explore and understand the ideas. And the problem with this is you get kids who finish their maths in your year level, they've covered all the curriculum, but they just don't understand any of it, and they've never had a chance to really engage with it. So I understand the pressure of time, but as much as you can, build in time for students to take their time and really explore deeply some of these mathematical ideas and play with them. Number 9, use a variety of teaching approaches and experiences. If you've ever bought into some of these theories like Gardner's thinking hats or all those sorts of things, they're all useful, but they're not a theory of how each person is. What it says is that all students have to do things in lots of different ways, and we need to provide variety so students can engage with things in different ways. So if you're only ever doing chalk and talk, not that you'd have any chalk anymore, but if you're only doing like lectures and the kids do exercise from a textbook, that's not good enough. It's not good teaching. Sometimes you might need to use it, but not all the time. Sometimes you need to do group work. Sometimes you need to give them extended problem-solving tasks. Sometimes you need to let them create things and play with ideas. And all these different things are important, and you need to have a balance of activities and teaching strategies and experiences that relate specifically to the learners in front of you and the content you're teaching at that time. The last point, support learning through assessment. Assessment is not the key thing that you build your learning towards. Assessment is something that supports the learning. And that means most of the assessment you do will be informal and formative in the class. As the kids are working on stuff, you'll be wandering around and watching them and helping them and making informal assessments of what they're doing. Help that guide their learning. Help that guide your teaching, because it lets you know what they've actually learned, not what you think they learned or what you wanted them to learn, but what they've actually learned from the experiences they have. So assessment is important, but not as important as the learning. It's only a way of supporting learning and occasionally recording what they've done or shown they can do. So, what's your job? Well, this is the easy part, just to talk about them. Your job is to put these things into practice with your school, with your students, with the relevant curriculum. And we're confident you can do it, as long as you really think deeply and carefully about the kids' teaching. And of course, at the moment you don't have any, but when you start, you'll be able to do it. I don't know if I've said this before, but there's no recipe, but we're really confident that if you can really take all these theories and ideas on board, you'll be able to create some great mathematics learning experiences and really help students develop strong mathematical identities. All the best.